In this video, we are going to see about solid, liquids and gases. All these three states of matter is based upon the movement and the temperature. So let's start with kinetic theory of matter. All matter is made up of an atom and molecules. They act as a tiny particles. Like all these tiny particles will always be in a movement, which means like when you increase temperature, the movement of the particle is going to increase. When you decrease the temperature, the movement of the particle is going to decrease. If it is at the same temperature, which means the movement of the particle for the solid is going to be AV compared to the lighter particles. Intermolecular force of attraction, which means the force of attraction between any two atoms. Like if we take a hydrogen and a chlorine, the force of attraction between this hydrogen and chlorine is known as the intermolecular force. For solids, if you take, the force of attraction is going to be very strong because the atoms are tightly packed in a solids. So strong force of attraction for the solid molecules, and for the gases, force of attraction is going to be very weak. Like all the states of matter is based upon the particle arrangement, energy of the particle and distance between this particle. For solids, if you take diamond as an example, so all the particles in a diamond, all the tiny particles in the diamond are closely packed, and like when you increase the temperature, right, they are going to vibrate only on its fixed position. They are regularly arranged. And what about the intermolecular force? The force of attraction is very strong, and when you increase the temperature, they are going to vibrate only on its part. So particles are held together by intermolecular forces. They are tightly packed and they are vibrating only on its fixed position, and they have a definite shape and a definite volume. Next, liquids. For the liquids, the particle arrangements are not close together. They are close together, but compared to a solid, it is little bit weak. For the intermolecular force is also, they are also having an intermolecular force, but weak intermolecular force is here, and they have an indefinite shape and a definite volume, which means if you are taking water in a beaker, right, and you are transferring it to a conical flask, so the water, like the it occupies the shape of the container. Like when it is in the beaker, liquid occupies the shape of the container, right. When you transfer to the conical flask, it's going to occupy the shape of the conical flask, so which means indefinite shape. Definite volume means if you are pouring 20 ml from the beaker to the conical flask, so the 20 ml is going to be same in the beaker as well as in the conical flask, so it has a definite volume. Next, gases. So here the particles are very far apart, which means they are free enough to move, right. So here the weak intermolecular forces is not there, so it is a very weak, and the intermolecular forces are completely broken now. And what about the shape? It doesn't have a shape, it doesn't have a volume. Like you can even squeeze it into the smaller place, which means like we can consider the carbonated drink which we are drinking, right. So we are like we have sent the gases to the container with some pressure, which means we are squeezing the gases into a container. So it is possible to squeeze the gases, but not liquids or solids. We cannot squeeze it, right. Then the interconversion between the three states of matter: solid, liquids and gases. So when we talk about the melting point is nothing but conversion from a solid to liquid. So solid to liquid, which means ice to a water, is known as the melting point. Then freezing point is liquid to solid, that is ice to water to a ice is a freezing point. The first point. Condensation is gas to liquid. When we evaporate, right, when we boil the water, the gases escapes, right. When we close it with the lid, that gases will become a liquid. So that is called gas to liquid. Again it condenses back, right, that liquid will come back. That gas will change to a liquid and it comes back to the water. Vaporization is liquid to a gas. Sublimation, solids to gas without goes through a liquid phase. Example, ammonium chloride, naphthalene and camphor. Let's go through. Solid particle arrangement is close together and they are regularly arranged, and the movement is going to be vibrate only on its parts. Liquids particles are close together and they have a random arrangement Liquids moves around each other. Gases, they are far apart and the arrangement is a random arrangement, and gases move quickly in air. And diffusion, the spreading up of gas or liquid is known as diffusion. What is diffusion? It is spreading from a high concentration to a low concentration. Example, instant stick, right? Like the smell flows from the high concentration and to all over the room. So that is one of the example. Diffusion in a liquid is slow because particles are arranged in a closed manner. Solubility, the maximum mass of solute that dissolves in 100 gram of solvent at a particular temperature. Example, sodium chloride and water. Okay, solute example is sodium chloride and solvent example is water. So if you are dissolving 36 gram of NaCl in 100 gram of water, so how much of mass is solute, like how much of maximum mass is get dissolved is known as the solubility. Thanks for watching video. Like, share and subscribe.